Right, we're going to start this magnetism type of worksheet. Right, I'm going to start hurting our brains. I tried it earlier. It went a bit kharab. Right. A device called a metal detector can be used to find metal buried underground. You've got a transmitter coil and you've got a receiver coil. Now, the metal detector has two circuits, each containing a coil of copper wire. Diagram, right, okay. Diagram 1 shows a circuit for the transmitter coil. So you've got your cell is single, and then if you've got more than one, it's a battery. That's what we learned from the previous things, yeah? Right, so guess why there's a magnetic field in the transmitter coil in there. What's happening is you have, because you have, there is current in the coil. And I think this is what I was going to describe last time. So I was going to describe last time. Right. So you've got a wire. Your current's going in that direction. And if you used your right hand and point your thumb, see how good I am at this now. That's your thumb. Right. And then you wrap your fingers around that's like your coil. No, that's not your coil, those are your fingers. So these are your fingers, so that's one finger, nail, another finger, another nail, another finger, another nail, and finally, that's your hand. World's greatest drawing, that's your nail. So the current is going in that direction. You wrap your right hand and point your thumb in the direction of the current and wrap your fingers around. So the field, the magnetic field, is going in that direction. Yeah. Going in that direction. Right. There you go. Let's move on. The cell supplies direct current and the electronics in the diagram change the direct current into alternating current. Right, that's interesting. The alternating current changes direction. That's the stuff that comes out of your socket, in the wall. That is alternating current. It's changing direction. It goes from plus 230 to minus 230. So plus 230 to minus 230. Right. Direct current is from batteries or cells, and it stays at a set level. Describe the difference between, right, okay. So direct current travels only, that's voltage, no, that's your time. And this can be voltage or current. In this case, they're talking about current. Direct current travels only in one direction, whilst AC continuously, if I can spell it, continuously changes direction. Right. Alternate current is supplied to the transmitter coil. Diagram shows the gold ring below. Explain why there's an alternating current in the gold ring. Right. So what's happened is there's a coil inside which is alternating that way. So let's just say the magnetic field I'm going to make it complicated. So you've got your magnetic field going that way and it's cutting the ring. Now if it was direct, it would not be moving, it would not be cutting that. Now because it goes that way and then it alternates and changes direction and then it goes the opposite way. This metal ring is being cut by this magnetic field. Because you've got a magnetic field cutting the metal, it induces a voltage. So that's what we've got to say. Best way to do is just learn it, yeah? So you have a changing magnetic field, from the coil cuts the gold ring cuts the gold ring, right? Or you can say that let's put it the other way. Let's get rid of that. So the changing magnetic field from the gold ring means the gold metal ring cuts the field lines from the coil. This leads when you've got magnetic field lines cutting a piece of metal, you end up with leads to an induced voltage in the gold ring. So you got changing magnetic field cuts the field lines field lines. It cuts the field lines from the coil. Right, so these are the three steps. These are the three steps that you need to know. So the changing magnetic field from the coil, So the changing magnetic field from the coil means that the metal ring is cutting the field lines. Right, you've got two options. You can either move the metal detector, or you can move the ring. In this case, the metal detector is moving, so that's causing the magnetic field lines to be cut by the ring. So cuts the field lines from the magnetic coil. This then leads to an induced voltage in the metal or in the gold ring. Right, those are the 3 points you've got to learn. And then this is standard answer once you know it. Right. And when you've got, let's just finish that off, right? We don't need to write this. So when you've got an induced voltage, you're going to get a flow of current. So it'll go in that direction, and then it'll go in that direction, but we don't need to worry about that. Right, diagram 3 shows the circuit for the receiver coil there and the loudspeaker. As a result of the alternating current in the gold ring, there's an alternating current in the receiving coil. Explain how the alternating current in the receiving coil causes a sound to be produced. Right, what this is, so we need to explain how that happens. Right, if I can draw this, if not I'll get you the diagram. So here's your permanent magnet. Right, that's your permanent magnet. Now, if I can get this right, it'll be good. You have your speaker coil here. So there's wires here that they're going up round. Let's go round and round. Right. And then attached to that is your speaker cone. That's your speaker cone. That's that round disc that you see in speakers like this, and then that's what vibrates. So what's going to happen is, I don't know if can I get all of them? No, I don't think I can. Oh yeah. So what happens is, look, there you go. Can I group them? There you go. So what happens? Not you. Right. So it vibrates like this, and as that vibrates, right? Okay, it might work. As that vibrates, then this here, the cone moves, forcing air to move, which then creates the sound wave. That's what's happening. Right, so now we need to put that into right, so remember this bit here is stationary. Stationary. That's stationary. So when a magnetic field is produced, a force is applied, and because this alternating current in the speaker core, in the cone core, it's going to produce a force, and that force will force this to move that way and that way and that way and that way. depending on the size of the current coming in or the signal coming in. Right, somehow we've got to put that into words. Oh my word. Right, let's try that. So there is an alternating current in the loudspeaker. So the magnetic field from the loudspeaker. So the magnetic field from the loudspeaker interacts or cuts with, I keep doing that, with the magnetic field from the cone. So let me do, when you've got an AC, so there you've got your AC supply, that generates a field, right? Now we've also got how would this work from north to south? So it would, you'd have a field, you've got a field there. Now this is the alternate, this is the moving field. This one is stationary. And they cut each other. When they cut each other, they generate a force. Because this here cannot move. You see that there? That cannot move. That forces the cone to move. That was that bit there. That forces the cone to move, which generates the sound. So that's what we've got to do. So first of all, there's an alternating current in the loudspeaker, so magnetic field from the loudspeaker no, so that, no, what they're saying is the AC is from here. So the magnetic field from the loudspeaker interacts with the magnetic field of the cone. Right. This causes a force. This causes force on the speaker cone. That's the speaker cone. Let's put that there to avoid confusing speaker cone. Right. So which will cause it to move or vibrate. Right. Since the alternating current is changing direction, the speaker cone will vibrate, causing sound to come out. Right. Ooh, that's a difficult one. Right. First of all, let's just can we get rid of these? Get rid of that. I don't think we can get rid of them, unfortunately. Yes, I am. So far, so good. There you go. Right. So, right, well, I got that one wrong actually. I should have done it the other way. Let me get that right. So you've got your AC being supplied here. So it's a bit long-winded this because we need to get this right in our heads on the first go. Then we just reapply it. So you've got your alternating current. That generates a, where are we? I'm looking for something. Let's just do that. That generates a field, a moving field, right? Magnetic field. You've also got a supply signal from there, and when you apply a voltage or a current through there, this will generate its own magnetic field. And can you see here they interact? Right, so that's going to induce a voltage in the speaker here. And because that's able to move and this big yellow thing isn't, right, that core there isn't able to move, it's stationary, that'll force, let me get this right, that'll force this mechanism here to move. That'll vibrate that way and that way, and that's what we've done, right? So let's go through that again. There's an AC in the loudspeaker, so the magnetic field from the loudspeaker cuts the magnetic field of the cone. Right, this causes a force on the speaker cone, which will cause it to move. Since the AC is changing direction, the speaker cone will vibrate. It'll move and then it'll stop moving, and then it'll move and it'll stop moving, so it'll cause it like a vibrating effect, causing the sound to come out. Ooh. Right. And yeah, these vibrations cause the sound. That we'll leave it at that. I'm gonna call it quits at this because this is dumb heading.